The EPS we're looking at today is from the Messenger spacecraft. Here's how it works. As the spacecraft orbits a planet, it's bombarded by electrons and charged particles from the solar wind. The EPS has a field of view of 160 by 12 degrees in which these particles can enter. When entering the EPS, particles first have to pass through the collimator. The collimator is made of full concentric rings with lots of holes in them. Their job is to make sure that the particles that hit the detector at any given angle are actually coming directly from that angle. It does this by making the particle go through precisely aligned holes in the four rings. Particles that are not head-on won't make it through all the rings, so it won't hit the detector. This is important because we're not just measuring the strength of a magnetic field, we're also measuring its shape. Now that we know the direction of the particle, we need to measure its mass to charge ratio. This is important for determining the type of particle. So right after the collimator, the particle will hit and go through a metal foil, which will cause electrons to be ejected. The electrons are attracted to the positively charged bottom plate, creating a signal that signifies the beginning of the particle's trip across the detector chamber. On the other side of the chamber is another metal foil, and when the particle hits that, it causes more electrons to be scattered. These are also attracted to the bottom positive plate and creates another signal that signifies the end of the particle's trip across the chamber. Given that the distance between begin and end fall is known, along with the begin and end time, we can calculate the speed of the particle. We now know the direction and speed of the particle. The only thing remaining is to measure its charge. This is done by one of 6 solid-state detectors, depending on the angle of entry. Each detector is divided into 4 separate subdetectors, 2 big ones, 2 little ones. The pair on the right is coated with a thin film of aluminum. This prevents protons from hitting the detector while letting electrons through. When the detectors are hit by charged particles, or electrons, a voltage is generated which is proportional to their charge. The 2 big subdetectors allows us to detect particles and electrons when there are very few, while the small one allows us to get good readings without saturation even when the influx of particles is high. Now we have all the pieces we need: direction, speed, and charge. For a given speed and charge, we use a lookup table to get the mass charge value of the particle, which can then be used to determine what kind of particle it is. Combine this information with knowing which direction the particle is coming from, and you'll have a really good picture of a planet's magnetic field. So this is how the energetic particle spectrometer works on the Messenger spacecraft.